So, long time no video. Well, not that long actually. But for the PCB series, it's been about a year since my last video. I've actually been pretty busy with other general stuff and hobbies, but as some of you are probably aware from my community posts, I finally got back to PCB making a couple of months ago, and I've been working on a pretty complex PCB for a real-world application. This is actually the first since the big precision upgrade of my CNC 3018, and as you can actually see by this big pile of failed PCBs, I did actually run into a number of problems, so that sort of dragged the whole process out a bit. And I've really been working hard to try to understand the various issues and improve the process generally wherever I can. I mean, most of these issues are not that critical. I could have just probably gone with it by working around or fudging it. But every time I make a PCB, I'm always trying to push the boundaries a bit. And of course, expecting a few problems along the way, and then looking for ways to address those problems properly. And by doing so, I'm actually ensuring that the process can continue to gradually improve. Now, this project that I've actually been working on is a hi-hat pedal for my electronic drum kit. In a physical drum kit, this would actually change the gap of the hi-hat cymbals, changing the sound from like a cha-cha-cha to sha-sha-sha or whatever. That's my little rendition for you. Actually, the original pedal that came with my secondhand drum kit, it's actually famously a terrible design. It's simply using a chunk of rubber to press down on a compressible potentiometer sheet. And even when it's new, it's pretty awful to use. But after about a year or so of use, it actually becomes absolutely unresponsive. Now, there are various ways to supposedly repair this, and there are heaps of YouTube videos out there about this. But in reality, you can't actually properly fix it, as the design is fundamentally flawed. It's actually really surprising and quite a shame because the design of the rest of the drum kit is pretty rock solid. So the basic design I came up with uses a AS5600 magnetic position sensor and a microcontroller working together to create a signal compatible with my electronic drum kit. I've also added a little OLED display for changing the settings, but this can also be used to provide visual cues to the player so you can understand how open or closed the hi-hat is. Obviously, with an acoustic drum set, you could just simply look at the hi-hat itself to see how open it is. So I'm thinking it could be some sort of an analog for that. The primary hardware for the pedal that I'm using actually comes from a cheap Chinese kick drum pedal I got from Amazon. I think it cost me around about $10, and I'm simply modifying that to suit my purpose. And of course, as it is an electronic device, it needs its own power. So I came up with a rechargeable battery solution, and that should mean I should only need to charge it once every couple of months or so. Actually, this is a pretty cool part of the design, and generally I think it makes a lot more sense than having to use a separate power cable just for this pedal. So yeah, I think that's about it. With that, you should hopefully have a very basic overview of this project. So to make this, I actually needed to come up with the basic concept: hardware design, electronics design, PCB design, make the PCB, design and 3D print heaps of parts, and also make a bunch of other hardware for the pedal itself. You know, the typical sort of stuff that goes into a project like this. And at the time of making this video, the hardware is finally fully complete, but the software isn't yet. I typically start making videos around the time of hardware completion, so I'll likely be switching between making videos and making the software over the next couple of weeks or so. Actually, in theory, there's plenty of stuff related to this project to make videos about and discuss. But sadly, whenever I make a detailed video about my practical projects, they really do get bugger all views. So it turns out to be a huge waste of time to make them, so I'm just not motivated at all to do it this time. Instead, what I've decided to do is make a small follow-up series to my PCB series based upon my experiences and what I've learned in general from this project with relation to my PCB process. I only think it's going to be super useful for anyone who's either considering or is already using my PCB process, or it just could be generally useful to anyone out there who's using their own process but wants to cherry pick some of the techniques that I demonstrate. Of course, if there's really a large number of viewers out there who really want me to get into the nitty-gritty of this hi-hat pedal project, you can show that to me by hitting the like button in this video, and if I get, say, 500 videos within 1 month of releasing this video, then I'll go ahead and make a video or two breaking down the various details of this hi-hat pedal project. And be sure to leave in the comments what topics you specifically want me to focus on. So I'm thinking this follow-up PCB series is likely going to be 4 or 5 episodes in total. It's going to be released at a pace depending on how quickly I can actually make them, and the pace might change a bit depending on how well they are received. I mean, if people seem interested and are actually watching the videos, then that always improves the motivation to pump out the videos. The video styles will probably be a little bit different to what I've released lately, being a lot shorter, less complicated production stuff, and generally more conversational. So it's going to be interesting to see how well that works out and if people actually watch them or not. Interestingly enough, recently YouTube has been heavily promoting this DIY PCB video to me from the Laser and Source channel. Honestly, not a channel that I'm familiar with, but it's in my recommendations like every single day. And it's nearly got 200k views in just 8 months since its release. So it must be pretty damn good. Definitely puts all my videos to shame, that's for sure. Now, I haven't actually watched that myself because, as you know, I rarely watch other people's PCB videos in order to keep my originality and motivation. I mean, the last thing you want to do is see something's already being done by somebody else that you wanted to do. You're not going to do it then, so I usually don't watch them. But even so, out of a sense of community, I thought if YouTube is promoting this video so hard, then it must be pretty damn good, right? And maybe it's going to be useful to some of my viewers out there. So if you haven't already seen it, then head over there and check it out. There's a link in the description. And make sure you let them know that ForOurGood sent you. So that's it for this video, short and sweet, more of a contextual setup video so you can make sense of why I'm making the following videos that you're going to see. Anyway, I hope you join me as I release each of those. And so, as usual, I'll see you then.